Time and tide wait for none, we have read already, right? So is the time going smoothly or not? Do you remember during the lockdown time? I think you were in the, maybe in the nursery or LKG class. Lockdown in 2072, 9 years ago. That means maybe class 1 or UKG, right? Lockdown, I'm talking.
We were in three and we were in four. After four completed, then we that is our corona is talking about our
Lockdown, earthquake time. Yes or no? Lockdown was a bit earlier than this corona time. Anyway, time is just running smoothly, and you are also achieving the goals, and your first term is already over, and your performance is already seen by Mr. Neopani. I saw it. But I found nobody has deserved GPA 4. To deserve GPA 4 is quite difficult. But it's not difficult as well. They are deserving also. And I was talking. Oh, please come. Uh, in SE 2081, students they have to labor too much hard to deserve GPA 4. But now, means in next year, in 2082, 2083, there are probable candidates. Like here is Arina Gubaju. Everything perfection. Krizal also she can do. And just now it came Nistara. She can deserve. Others also you can try. In class 8, who are studying right now, they are also probable. There is Nirajan, smart boy. And if one person is smarter one, then he makes others also smart. And we are going to learn from smart board also. Because our school is smart school. And you are, then I am teacher. Oh my God. Okay, children. Yesterday, what did we discuss? We were discussing about this um, velocity, acceleration, etc. See, what is given here? Uniform and non-uniform velocity. If a person travels equal distance, please try to understand, equal distance in equal interval of time, then it is called uniform velocity. This guy travels 2 meter in 1 second, 2 meter in 1 second, 2 meter in 1 second. So, what is the velocity here? Same or different? 2 meter per second, 2 meter per second, 2 meter per second. Such type of velocity is called, what is it called? Uniform velocity. But next one is non-uniform velocity. This guy is a bit fun to. Here he traveled 2 meter in 1 second. Here 1 meter in 1 second. 4 meter in 1 second. So what is the velocity here? Here and here. So such type of velocity is called non-uniform velocity. So why don't you come on time, master? No, no. So actually, people, what do they say? What do they say? Sir, difficult to manage time, but it's not difficult. We are the candidate to manage time. Understood, Anand? There are some people who can study nicely also, who do their work very nicely also, and they use internet very nicely also. They are managing time. So time management is important. Today is the last day to remind you. From tomorrow, I will not remind. I will straight send you back to class 8. Why do you keep you in class 9? Right? So class 9's class is going on. If the person cannot come and try time, means what to do? He is fit for class 8. And if you are not fit in class 8, then again go back to class 7. Demotion. Promotion. What do you call? Demotion. We are discussing about the chapter force and motion. Yes or no? Okay, non-uniform velocity. So we discussed negative acceleration is, what is that? Retardation. Yes or no? In acceleration, final velocity is greater than initial velocity. In retardation, final velocity is lesser than initial velocity. Okay, you just check here. What is the velocity here? Here, here, here. So velocity is increasing, right? In such case, what do you get? Acceleration. See, when you compare these two velocities, initial velocity is 0 meter per second, final velocity is 2 meter per second. When you compare this velocity and this velocity, initial velocity is how much? 6. So In this case, velocity is in increasing order, so there is acceleration. But in deceleration, at the beginning, it travels very fast. Velocity is more, like here is 10 meter per second and here is 4 meter per second. At the beginning, how much? Here means velocity is increasing or decreasing. That is called retardation. Okay, retardation. What is the formula to calculate acceleration? V minus u by t. What is V? Final velocity. What is u? What is t? Time taken. What is the SI unit of acceleration? Meter per second square, right? So it's given here. One numerical problem is given. Let's check here. Read the question. What is given? If a car traveling at a velocity of 4 meter per second along a straight line speeds up uniformly to the velocity of 6 meter per second in 2 seconds, find the acceleration. So here we have to mark. What is this 4 meter per second? Initial velocity. And 6 meter per second. What is this? Final velocity. That means this is u, this is v. In 2 seconds means what is it? T, time, right? So what is the formula of A? V minus u by t. V is how much? 6 minus how much? 4 by 2. 6 minus 4 is 2 by 2. 2 by 2 is 1 meter. What is the SI unit of acceleration? Per second square, right? Take out your copy, do one numerical problem. Okay, I'll just modify something and then give the question. If a car traveling at a speed of 15 meter per second okay, the question is like this, and you have got hardly 2 minutes. How much time is given? 2 minute time is given, eh? A car traveling at a velocity of 15 meter per second along a straight line speeds up uniformly to the velocity of 30 meter per second in 5 seconds. Find the acceleration. The task you can do later on. Now let me welcome on the stage to present the slide. Today's first presenter is, with the first presenter, Nikisha Manandhar. Please come. Nikisha, I think this is your slide, right? So you can do go in size slow and from beginning. Is there animation as well? No, animation is slow. Okay, but just take it.
Respected house,
Please pay attention, everyone.
respected house science teacher, my dear friends. As you all know, it's Nikisha from grade 9, standing here to give a presentation of the topic force and motion. Graphical presentation of linear motion. Graph is a convenient method to present the basic information about different events. To describe the motion of an object, we use line graphs. Line graphs show dependence of velocity or displacement on time. Now we are going to discuss the displacement graph, time graph, and velocity time graph. Displacement time graph represent the interrelation between the change in position on a straight line and the time taken to bring the change in the position of a body. In this graph, the time is represented along the axis and x-axis, and displacement is taken along the y-axis, and the velocity of time displacement time graph is represented as v velocity is equals to x2 minus x1 divided by t2 minus t1. Velocity time graph, we can express the relation of time and velocity in graph. A velocity time graph shows the speed and direction traveled by a object over a specific period of time. It is also called speed time graph. Velocity of the object is expressed at the vertical axis and time at the horizontal axis of a velocity time graph. In a velocity time graph, the horizontal time line indicates the uniform constant velocity. If the horizontal line is at zero velocity, is shows that the object is at zero velocity is shows that the object is at rest, and this is the figure figure of uniform velocity and non-uniform velocity shown in the line AB can be calculated as follows. This is the time velocity in meter per second. A is equals to u minus v minus u divided by t, and 5 minus 0 divided by 2, 2.5 meter per second square. We can calculate the relation shown in the line AC as follows. A is equals to v minus u divided by t, 4 minus 0 divided by 3, 1.33 meter per second square. Thank you.
Thank you very much. So let me say something, then afterwards I will call next presenter of today. Right? So very nice slide is made. Uh, actually, she has explained about two graphs, right? What is that? Displacement time graph and velocity time graph. Displacement time graph, it shows the velocity of the object, right? And velocity time graph shows the acceleration of the object. Understood, Anand? Check here. Here is given uniform velocity and non-uniform velocity. In uniform velocity, equal distance is traveled in equal interval of time. See, what type of line is here? Are they parallel lines or not? If you get such parallel lines, what is that? Uniform velocity. Equal distance, equal time. Now, here is the next one. Non-uniform. Equal distance, unequal interval of time. Or unequal distance, equal interval of time. So, in this side, distance is shown. This side, what is shown? Time is shown. So just check here. Parallel lines, it shows uniform velocity, and oblique line, what does it show? Non-uniform velocity. Parallel, uniform, oblique, non-uniform. And again, next one is here. Interval means difference. Interval of time means like this is time, right? 0 to 1, 1 to 2 means what is the interval of 0 to 1? 1. 0 to 3? 3. 0 to 5? 5. 2 to 5? 3. Interval means difference. Interval means difference. Like 1 to 7, what is the interval? 6. 3 to 8? 5. 5 and 3? 2. 5 minus 3. 1 and 6? 5. That is interval. Okay. And this graph is very important. Sometimes question can be asked from this graph also. Check here. This side. This is x-axis. Yes or no? And this is x-axis and this is y-axis. What is shown in x-axis? Time. Y-axis, velocity. See, it is going straight up. Wait. If it is going straight up means velocity is in increasing order or decreasing order. So it shows acceleration. What does it show? And what about this line? What does it show? Acceleration. This also shows. Why? Velocity is increasing. But this line, what does it show? Retardation. Why does it show retardation? Velocity is decreasing, right? And this line, what does it show? It shows constant velocity. What is it? And what is the acceleration here? 0. Because initial is how much? 4 meter per second. Finally is how much? 4 meter per second. Because see, you look at this line, no? 4 meters per second, 4 meter per second. And what is the difference between 4 and 4? 0. Means acceleration is how much? 0. Can you find the acceleration in this side? How much is it? 4 minus 0. 4 minus 0 is how much? 4. And what is the time? 4 minus 4 by 3 is how much? 4 by 3 means how much? 1.33 meter per second square. So in this line, in this case, acceleration is 1.33 meter per second square. But in this case, what is the retardation? How much is here? 0 minus how much? 4, because here is 4, no? 0 minus 4 by 4 by means here to here. What is the interval? How 6? The interval is like that, no? Here is the here means when the time is 6 seconds, velocity is how much? 4 meter per second. When it becomes 8 seconds, velocity is how much? 0. So 0 minus 4 divided by how much? 2. It comes minus 2 by 2 means minus 1 meter per second square. But when you say retardation is written as minus a equals to 1 meter per second square. Okay. Again, I will make it clear. Like another thing. What is the acceleration in this side? Do you know? It goes from 0 to 5. What is the acceleration? Acceleration equals to formula v minus u by t. What is v? Here is 5. Minus u is how much? 0. Time is how much? See your time. Interval is 2. Just you see. 0 to 2 means 2. Okay. Suppose here is another one. 0 to how much is here? 4 meter per second. No, time is 5, but velocity, how much velocity? 4. So 4 minus 0 is how much? 4 divided by 5 minus 0 means 5. Means 4 by 5 is 0.8 meter per second square. In this line, acceleration is increase or decrease? Decrease. Here in acceleration is more or less. But what about the acceleration in this line? From 0 to this 6. Find out.
4 by 6.
What is the acceleration? 4 by 6. Because final velocity is how much? Initial velocity? 0. And time taken? Interval is 6 minus 0 is 6. So 4 by 6 means how much does it come? 0.66 meter per second. Year 2. Year 2 means time division. Your time is year 2 second. Now tell you come here. Which line you want to say? Where you are confused, you tell me. I'll just make you to say. There 2. Oh, okay, good. Then what is the interval? No. Okay, good. See, a little bit confused here. Her saying is 4 minus 0 by 6, she said. What is the time here? 8. Here is 6. 6 to 8 means what is the interval here? This interval we have to find. You thought this one, not like that. So, when it was 6 seconds, what was the velocity? 4 meter per second. When it was 8 seconds, what was the velocity? Then what is the difference in time? Difference we have to see. We should not see this initial one. Otherwise, you could write here 0 also earlier.
No, it is because of retardation, that's why.
Not retardation. What is the time difference?
But in this line, we didn't do minus. No, like
Where? Like, okay. What is the acceleration here, eh? Here, 4 minus 0. What is the difference? 3 minus 0 is 3. You might have thought that here was 3, that's why I written 3. Not like that. we have to find this gap. We have to find the gap. Is it clear or not? If it is unclear, please ask. This is the time to learn. You don't understand, and you say you understood, and it becomes difficult. Not like that. So velocity, you see, final velocity, initial velocity. What is the gap? Understood or not? Okay. All right. That is all. So she has calculated like that. Now, students, we are going to discuss next slide. So force and motion, WPS Office PPT, and the next presenter is Sushil Chand. Let's welcome him on the show. Please understand afterwards. I will give you some time.
Namaskar and very warm good morning to you all. This is Sushil from grade 9 from group A, standing here to present about equation of motion. The equation involving displacement as initial velocity u, final velocity v, acceleration and time of motion of moving body as the equation of motion. These equations are derived from the definition of average velocity and acceleration. Consider a body moving on a straight line with uniform acceleration as shown in the diagram. Uh, Relation between initial velocity, final velocity, acceleration and time, or first equation. A body has initial velocity u and it's subjected to a uniform acceleration a, so that final velocity b v after time interval t. Now by definition of acceleration we have a is equal to v minus u by t. uh, at is equal to v minus u. Here is equation, first equation, v is equal to u plus at. Relation between s, u, v and t, or second equation. Here is av is equal to u plus v by 2. Average velocity is also calculated by av is equal to s by t. From equation 1 and 2, u plus v by 2 is equal to s by t, or 2s is equal to u plus v t. Therefore, s is equal to u plus v by 2 into t. Relation between s, u, a and t, or third equation. V is equal to u plus at, s is equal to u plus v by 2 into t. Putting the value of v from the equation I in the equation from the equation first in the equation second, we have s is equal to u plus bracket u plus at by 2 into t, or s is equal to 2u plus at t by 2, or s is equal to 2ut by 2 plus at square by 2. Now third equation is s is equal to ut plus 1 by 2 at square. Relation between u, v, a and s, or fourth equation. V is equal to u plus at, s is equal to u plus v by 2 into t. Now putting the value of t from equation I in the equation I. S is equal to u plus b by 2 into b minus u by a, or s is equal to b square minus u square by 2a, or 2as is equal to b square minus u square. Now fourth equation is b square is equal to u square plus 2as. Application of equation of motion in different situation. Case 1. For a body moving with a uniform velocity, initial velocity u is equal to final velocity, hence acceleration is equal to 0. Therefore, from the equation third we have s is equal to ut plus 1 by 2 at square, s is equal to ut 1 by 2 at square is equal to 0. Case 2. For a freely falling body under gravity, a is equal to g and s is equal to h. Equations first, second, and third, and first, second, third, and fourth are respectively written as v is equal to u plus at, v is equal to u plus gt, s is equal to u plus p by 2 into t, and h is equal to u plus p by 2 into t. S is equal to u plus 1 by 2 at square, and h is equal to ut plus 1 by 2 gt square. V square is equal to u square plus 2as, and v square is equal to u square plus 2gh. In case 3, for a body just released from a height h, u is equal to 0, a is equal to g, and s is equal to h, then the equation of motion become v is equal to u plus at and v is equal to gt. S is equal to ut plus 1 by 2 at square. Then h is equal to 1 by 2 gt square. V square is equal to u square plus 2as, and v square is equal to 2gh. Thank you. Have a nice day.
Okay, thank you. Actually, these are very important. These are very important things to do. And after this, I think there are some numerical problems, right? What are there? Numerical problems. Okay, children, see here, eh? Subhat. Last time also we have discussed about Subhat. S U V A T. These five terms they come under equation of motion, right? What is S? What is S? Distance covered or distance traveled. What is U? Initial velocity. What is V? Final velocity. What is A? Acceleration. Or sometimes there may be deceleration also. What deceleration? Negative acceleration or retardation is also called deceleration. And what is T? Time taken. Right? So, altogether, there are four equations of motion. Yeah, just mentioned there. What is the first one? What is second one? What is third one? What is fourth one? What is first one? First one is V equals to U plus AT. How many letters are here altogether? How many letters are here? 1, 2, 3, 4. Out of 4, if you know 3, then you can find out fourth one, right? Final velocity, initial velocity, acceleration, time taken. S equals to U plus V by 2 times T. Second equation. First one is V equals to U plus AT. Second one, U plus V by 2 times T. Third one, S equals to UT plus half AT square. And fourth one is V square equals to U square plus 2AS. These four equations you have to keep in mind. What are they? What are the four equations of motion? V equals to U plus AT, S equals to U plus V by 2 times T, S equals to UT plus half AT square, V square equals to U square plus 2AS. So, in each case, there are four terms, four letters. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. Out of 4, if you know 3, then you can find out. For example, if there is given A, V, and S, what is given? A, V, and S, then how will you count? How will you calculate U? Which formula will you apply? Last formula? That's right. Yes or no? If there is given U and A and T, then how will you find out V? First formula. Which one is lacking? You can use that one. Suppose it's not given T. T is not given. So U is given, V is given, A is given. Which formula do you apply? Third one. But here in third, here is S. We can go through first one. Is it? V U T A. Understood or not? It's not given S. Not given S, but given A, U, and T. Which formula do you apply? Second is okay. In second, there is V also, but there is no V. Third one. That's why these four formulae must be remembered. What are these four formulae? V equals to U plus AT. Second one, S equals to UT plus half AT square. S equals to U plus V by 2 times T. Last one, V square equals to U square plus 2AS. Now, their derivation is also very simple. So, how will you find out V equals to U plus AT? Very simple. But this explanation should be written, everybody. Listen, hey, what is written here? A body has initial velocity u and it's subjected to a uniform acceleration a, so that the final velocity be v after time t. Now, by the definition of acceleration, so what to mention here? What is the formula of acceleration? A equals to v minus u by t. Now cross multiply. V minus u equals to how much is here? 80. V equals to u plus 80. Derive easily or not? Children, listen here. You must not forget to write these things for every derivation. So we know that A equals to V minus u by t, V minus u equals to 80, V equals to 80, derived. Question can be asked. Derive this equation. Then only you can do it. Right? Next one is, how do you derive S equals to u plus v by 2 times t? To derive this one, we know that average velocity equals to u plus v by 2. What is the first equation? Average velocity equals to u plus v by 2. Again, average velocity, there is one formula. What is that? S by t. How many equations have we got? Average velocity equals to u plus v by 2. Average velocity equals to s by t. Then from equation 1 and 2, we get, what do you get? S by t equals to u plus v by 2. Then you just take this one there. S equals to u plus v by 2 times t. Have you derived or not? This derivation is very important. Alright? And what did I give you yesterday? I gave you that graphical presentation, right? Now you haven't drawn?
You have given 3 questions.
Which question were they?
Define balanced and unbalanced force differentiate between them. Draw diagram to show distance and displacement. Define vector and scalar quantity with shape examples.
Okay, now one question I will give you. Okay, please take out your copy. Solve the following questions. Number 1, draw a graph to show uniform motion. See, uniform motion is here.
So we should draw graph or we should make
You have to draw graph, drawing graph. Okay, draw a diagram to show, draw a graph to show uniform motion, or show uniform motion in a graph. That is also the question. Show uniform motion in graph. Show non-uniform motion in graph. Second question. Sorry, different. So number 1. So graph means you have to draw line and then make like that. If you paste, that is also okay. Do you have?
Yeah.
Okay, draw. So uniform motion in graph, number 1. So non-uniform motion in graph. So time displacement in graph. Time displacement in graph. So uniform velocity and acceleration in a graph. Oh, so many graphs are there today, right? So uniform velocity and acceleration in graph.
You can paste that.
You can draw in, no, you can mark in your graph paper and paste it. Remember. Now,
So uniform of velocity and acceleration.
In graph, yeah. Now the last question is derive the following. Okay. What is last one? Derive the following. First question is in number I, V equals to U plus AT. Where are you looking, Sonima? Keep it like that. V equals to U plus AT. Second one is S equals to U plus V by 2 times T. U plus V by 2 times T. Third one is S equals to UT plus half AT square. And fourth one is B square equals to U square plus 2AS. These all derivations are very, very important because you have to solve many questions based on these equations of motion. Okay, have you got the lollipop or not? So if lollipop is ready, then why not to eat? Start eating now.